Hi, my name is Katie, and I'm the driver for the session, and I'm here with.
Hello everyone, my name is Ulrich and today I'll be the navigating session.
Okay. Um, so today we are covering chapter 18 and appendix A, which is chapter 19. Okay, let me just get a simple explanation about what chapter 18 is about. So chapter 18 is threads and concurrency. So a thread is like a mini program running inside the main program. So it lets your app do multiple things at once, like playing music while waiting for user input. So basically, it runs many methods at the same time. Next, we have the race condition. So when two threads try to access or change the same data at the same time, and the result depends on who gets there first, it can cause random bugs that are hard to find. So example, two threads updating a score, sometimes the final score is wrong because they clash. Next, we have synchronization. This is how you protect their data. So only one thread can use it at a time. So you use synchronize keyword to lock a method or block of code. Here we have an example. So only one thread can run update score at a time and the others must wait. So an example of synchronization is like you need an access card to go into a certain room in a building. So maybe only one person is allowed with the access card. So the person uses the access card to access the room. The next person has to wait until the person in the room is done in the room and comes out and hands the next person the key card. So that's how it works. Next we have the runnable interface. So this is a way to define what a thread should do. So you write your task inside a run method. So here we have an example. Here we're declaring it. So this is the code that runs the thread. Next we have the executor service, a modern way to manage threads. Instead of creating threads manually, you use a thread pool that handles tasks efficiently. Example. Well, a thread safe collection. Some collections like copy on write arrays are designed to work safely for multiple threads. They avoid concurrent modification exception and keep your data clean. So in summary, chapter 18 teaches you how to run multiple tasks at once using threads, avoid bugs caused by threads clashing, use synchronization to protect the shared data, and lastly, use modern tools like executor servers and thread safe collections. Okay, so now I'm going to explain code and yeah, and I'll run it and we will see. Okay. Mm. Okay, so here we just have our necessary imports. Um, and then over here, if we take a look, this just formats the time, and this is a medium style time format. Next, we create a thread over here. So we create a thread safe list to store the chat message. Copy and write array list allows safe rendering and writing from multiple threads. Next, we create a thread pool with 3 threads. This pool will run tasks concurrently. Here we submit the task in the thread each time submitting this loop runs 5 times, each submitting 3 tasks. And here we add a new task to the message chat to the list. Here we have tasks 2 and 3. So these may run before or after the message is added depending on the thread timing. Here we shut down the thread pool after all the tasks are submitted, this tells the executor to stop accepting new tasks. Here, let me just highlight. Here we have the check class that represents a single chat message. Here we store the message in a text, and then over here we store the time message that was created. Next, we have the constructor that sets the message and captures the current time. And then over here, we capture the exact time of the creation. Here we have a toString that returns a formatted version of the chat message. So here we formatting the timestamp using the medium style time. And then here we just combine the time message to display. So I'm going to run it and we should see that. Okay, so as you can see, we have the timestamps, and if okay, how do I show you the current time? I didn't set that, so I'll just Google. No, I'll just do this. Uh, I'm not sure if you can see the time if I do this. Okay, that does not work. Okay, so it doesn't work. But anyway, this is the current time. And as you can see, there the timestamps to come up, and then there is our message from our threads. Hi there, hi there, hi there. And that is it for chapter 18. Next, I'll be going over the appendix, which is chapter 19. So here we have a beatbox final club, final, and here we have the music server. So I'm going to explain the code, and then we will move to the music server. So here we importing our variable. It's quite a lot, but I'll go over it. Okay. So this is the GUI component to display the list of incoming messages sequences from other users. This is the text area user for the user to type their message. This list holds the checkboxes representing the beats. Here we have the vector to store the incoming messages from other users, the map to store other user sequence by the user ID or message. Here we store the user's name. This keeps track of the sequence number for messages from the user. This is for sending the data to the server. This is for receiving data from the server. Here we have the MIDI sequencer components, and this is the array instrument names to be displayed in the GUI. Here we have the corresponding MIDI instrument key numbers. Now moving on, we have the main method. So this is the entry point of the application. So here we use a default name if no argument is given, as we can see. And then next we have the setup method. So this just initializes the client connection to get sorry to set up the application. Here we open up the connection. So here we have our trying catch. So it attempts to connect to the server at localhost on port 4242. So the IP address will appear invalid likely because there is a typo over there. And then here we create the output stream for sending data to the server. Here we create the input stream for receiving data from the server. Here we run separate threads to listen for incoming data from the server, and then here we have our catch. If the connection fails, it will print a message allowing local play only. Okay. Here we initialize the MIDI system. Here we build the graphical user interface. Here the constructor. Here we build the GUI. So the constructors and the graphical user interface for the beatbox. Um, so we have the layout, we have the background, we have the border. Here we have the vertical box for the buttons and other controls. Here we have the button to start playing the beat. Here we have the button to stop playing the beat. Here we have the button to increase the tempo. Here we have the button to decrease the tempo. Here we have the button to send a message and the beat pattern to the server. Here we have the text area for the user. Here we list to display incoming messages and sequences. Here we have the vertical box for instrument labels. Here we add the components to the background panel. Here's a grid for the check boxes, so 16 by 16 for instruments and beats. Here we initialize the checkboxes for beat patterns and we set the frame properties and display. Here we have the MIDI setup. So it sets up the MIDI sequencer, sequence, and track. Here we build track and play. So it builds the MIDI track from checkboxes and starts the playback. Here we clearing existing tracks. Um, my mouse is stuck. Sorry. Um, for each instrument, check each beat. So here we just have a for loop to check each instrument, and then another for loop that checks each beat for the instrument. Here we add events to track, and here we add a control change event, which is the sustain pedal off. Here we add a program to change the events for the percussion channel. Here we have our try, so this just sets and starts the sequencer. Next we have the tempo control. This just adjusts the playback tempo by a multiplier. Here we send message in the track, so it sends the user's message and beat pattern to the server. Here we capture the current checkbox's state. Next we have our try and catch again, so it just writes the user's name, sequence number, and the message. Here we write the beat pattern, and if it goes wrong, we will get a printer message over there. Next we use a message settings. This is where we clear the message field. Here we listen for incoming sequences, so this just listens for selecting incoming sequence from the list. Here we get started on the selected sequence state. Here we update the logo checkboxes. Here we stop the current playback and rebuild or start the new sequence. Here we load the selected sequence, so it updates the checkboxes to match a selected incoming sequence. Here we create the MIDI events. It is on notes and notes of events to track for a list of keys. And then here we add a note to the event. Here we add note of event 1 tick later. Next we have the helper method. So we create the MIDI event. So it creates a MIDI event with the given parameters. And lastly we have a thread. So this just receives data from the server. So runnable to handle incoming data from the server in a separate thread. Here we continuously read objects from the input. Here we read a message, username and text, read beat button. Here we store the map and add it to the list factor, and here we update the incoming list UI. That is it for the Beatbox final. Next we are moving on to the Java server. Okay, so here we have the server class handling multiple client connections for broadcasting beat patterns. Next we list sorry Next, we'll just to keep track of all the connected clients output streams, and then we synchronize implicitly via add or remove. But for safety, we use ArrayList, not thread safe, but manage in this context. Here we have the entry point to start the server. This starts the server, the go method. Next, we have the main server loop to accept connections. So here we create the server socket listening on port 4242. Here we create a thread pool to handle multiple client connections. Here we continuously listen for client connections and accept incoming client connections. Here we create an output stream to send data to the client. Here we store the client's output stream in the last synchronized access if needed, but there is a single thread addition. Here we create a new handler for this client and run it in a separate thread. Here we log that a new connection has been made, and this is a print any server-side error. Next, the method to send messages and B data to all connected clients. Here we broadcast the received message and sequence it to everybody. So here we iterate over a copy or synchronize if multiple thread modification occur, but here it's safe. Next, we send a message, example username plus chat to the client. Next, we send the beat pattern data to each client, and here we handle the error in writing to a client if a client got disconnected or something. Here we have the inner class to handle the input from a connected client. Each client has its own handler running in a separate thread. The constructor sets up input stream from client, um, and we continuously read objects sent by clients as long as data is coming from the client. And here we read beat data after the message. Here we log and forward path objects to all clients, and then we have a catch handler. So here we handle communications error like the client got disconnected or an invalid object. So I'm going to run both, but I'm not going to connect it to my partner server because it does not work, it gives an error. See, as you can see, cannot connect, you'll have to play alone. But as we can see, here we have the beat box. Here I can send a message. Yeah, I get an error. But that is it. And that is it for chapter 18 and 19. Thank you for watching.